Abby. So Abby is the director and principal consultant at Capstone Analytics. He provides enterprise Power BI solutions to clients and specializes in the design and deployment of enterprise-grade Power BI semantic models. And Abby's going to be talking to us about technical learnings from developing and deploying enterprise-grade Power BI semantic models. So with that, I'll hand over to you, Abby. Thank you.
Thank you, Craig and Gilbert. It's been a while since I've attended this group. I know it's all online now, but yeah, life's been busy. I became a first-time dad 4 months ago, so that's keeping me really busy. But I thought I'll just end this year with some learnings from what I've been doing in the last few years. So which is just building enterprise solutions. So I've got a slide here which I'll share, and I'll go through some of these ones. So screen window tab. I see some familiar faces in the list. So welcome back, all of you. And if you're new as well, welcome to the group. So everybody can see my screen?
Yeah, we see Teams in the browser.
Okay. So let me do this again. So okay, I had to pick the right window. What about now?
Yes, we're seeing PowerPoint.
Awesome. Technology issues always. Apparently, the reason why I couldn't log in was because my VPN was on. So Microsoft doesn't want me on VPN. So I have to turn my VPN off. Anyway, all good. All right. So technical learnings from developing and deploying enterprise-grade semantic models. This is pretty much derived from a few blog articles I wrote earlier in the year, just based on my experiences and just some general and technical musings on developing enterprise-grade models. Obviously, in the last, I guess it was last month, Microsoft has changed dataset renamed to semantic models. So everything is a semantic model now. So I thought I'll just share my learnings here. I've got a fair few slides, so feel free to ask questions in the chat or even interrupt me if possible, or maybe just ask the questions in the end. All right, so for those of you who don't know me, and probably for those of you who know me as well, so why should you listen to me? It's December, and I'm pretty sure there are a lot of activities happening at this time of the year. So appreciate the time to come and listen to me. I've got experience in building terrible semantic models. As you do with building anything in life when you're starting out, you are not really good at doing things. So, but as long as you learn from those mistakes and apply them on your next project, you get better. So I guess I took those learnings to build some really good semantic models. My 7 years of Power BI experience may or may not have helped in that regard. I hope it has helped in some way. But the most important reason is I do love a good meme. Memes are great stress busters, and you will see them sprinkled across this presentation. So before I go to the learnings, I'll just what's in store. I'll talk about the what and whys of semantic modeling. So what exactly is a semantic model? Why do we need one? And then I'll talk about the learnings, which will be divided into 4 sections. That's design, build, deploy, and support. So when you work as a semantic modeler, I think these are pretty much the main functions you'll be working on. So design and ideate, which is really important, right? Because that's where you set the foundation for your models. And then you actually build the models based on your design. And then you have to deploy it, which includes testing as well. And last but not the least, you have to support it via source control or documentation and even optimizing the models. So what is an enterprise semantic model? So this is my definition. I've thought long and hard about it, so I've come up with this one. So a semantic data model is a single source of truth physical data asset which contains governed organizational metrics of enterprise data, which can be queried by end users to generate insights. It's quite a mouthful, but the key things to note here is that it's a single source of truth for uh, governed organizational metrics of enterprise data, and it's a physical data asset, so something which you can query. So it's not a logical model. So if we take an example of, say, banking, so what could be an enterprise data for banking? So banks have customers, so that's their core business, and customers have bank accounts. So they have savings accounts, transactions, home loans, and personal loans and whatnot. So that is enterprise data. So data which is a core part of the business and which is and on which the business relies on to do its on which the enterprise relies on to do its business. Governed organizational metrics. So each enterprise, so in terms of banking, you would have a core set of metrics which would be important for customer account data. So as in, how many customers do you have? What are their account balances? How many customers do we have coming in? How many customers do we have going out? How many home loans do we have? So these would be some of the core metrics, and someone in the business needs to define some of these metrics or measures. Like, for example, what is a customer? Is a customer someone who has a bank account, or is a customer who is someone who has a bank account and balance of more than zero? Because you might have customers who have a bank account but they don't have a balance in their accounts for years. Do they count as customers? So so these kind of definitions. So someone in the business should be able to define these core metrics. And once you define these metrics or measures, you would need to implement them in the model. And ideally, you'd want them in just one model and not just in multiple places. So that's the single version of truth. So that's the example of banking, right? So in a really simplified enterprise analytics platform, this I'm talking about Microsoft Stack. So you'd have your source system. So in this case, all your bank account data. So which would flow into a data lake, and then you would have one or two integration and transformation layers where the data gets transformed and massaged into something usable for reporting, and that gets loaded into a data warehouse. And then you would have what we call a semantic layer, so where you would define views based on your reporting needs, and then you would import it into a Power BI model which then you would publish into service, and then your reports would actually query that one model and then share it via apps. So just one model and the reports querying the model, that one model instead of querying the views. So, and that's very important because that's how they get that single version of truth. So that's your semantic model. But what is the problem that needs to be solved? So why do we actually need one, right? Multiple sources of truth. So if we didn't have an enterprise model, so users would connect to views or heavens forbid, a source system and create a lot of disparate models. So you would have, instead of having one model, you could have 5 or 10. So instead of account balance being defined in one model, you could have it defined separately in 5 models. So which creates a governance nightmares because it's really impossible to govern many such models, which might give you different answers. And this makes it inaccurate and unreliable because you have different models or reports giving different answers for the same metrics. I think we all have been there in projects where you often get complaints from stakeholders that this measure is not matching across multiple dashboards or reports. So which really makes the decision-making process a lot slower because you're constantly fighting fires instead of actually using these metrics to generate your insights. So what's the outcome then? So the outcome of the semantic model is it removes need for end users to query source system or even the views. So, and by having that single version of truth for the governed metrics, the users know that not only are they getting the same answer across all reports, but it's the exact same definition which is being applied. So when they go to a meeting or when they present their dashboards, everybody is on the same page, and everyone knows the business definition used for those measures. So, and this leads to really accurate and reliable reporting because not only have the measures been formally defined by data custodians and implemented, they've been thoroughly tested as well, which leads to expedition of the decision-making process because now your sole focus is to generate those insights and to take some actions, so you're not fighting fires at all. So we now have learned what is the semantic models and why we need one. So I'll just talk about the technical learnings. So we'll talk about the design first, which is probably the most important step, and that's where I feel a lot of organizations struggle because because the foundation they're built on is just not strong enough. It's pretty wobbly. So this is the first meme, right? So design, it doesn't have to be complex. The more time you put into designing something, the better you become. But yeah, if you go straight into build without doing the design, you will like you're born for failure. So the semantic model design is shaped by reporting requirements. So a data warehouse is not a semantic model. A data warehouses conform to some industry level standards for your fact and TIM tables, but they are not the ideal place to actually define your measures or even query them. For example, in the banking example, you might have a fact table for monthly snapshots of your accounts. So, however million customer accounts you have, you would have a snapshot of their account balance at the end of the month. And you would have another fact table for a number of members who've joined each day or each month. But you probably wouldn't have a fact table for counting the number of members. So because the number of members would actually be determined from the monthly snapshot table. So it would be more like a distinct count of the member IDs from the snapshot table. So you would probably create a view to get the latest member count. So you would start with the bus matrix to actually determine what views are needed. So the bus matrix is a standard way of getting your facts and dimensions, and then your measures as well. So if you're doing it for the first time, you will probably not get it right. You might take a few iterations to get your semantic model right, and that is okay, because at the end of the day, if you're building something from scratch, you just do not know what the end state might look like. So it might take you a few iterations. So as I said, so use views. So because with views, so you can give business-friendly names, and you can remove all of the columns which are actually all of the metadata columns which are part of the tables but don't have to be part of the views. And the other advantage is you can use logic from multiple fact tables into views, which especially if you're using those views across for multiple measures, you can do that easily from views. And as much as possible, you would like to make the views reusable for multiple measure definitions. You wouldn't want to create a view, a one-on-one relation for a view with a measure. So if you have, say, 50 measures in your enterprise model, you wouldn't want to create 50 views for those. It's going to be hard to develop, hard to deploy, and very hard to maintain as well. So as much as possible, views should serve multiple measure definitions. And this is also a core component. Apply your transformations as left as possible. So move your reusable logic as close to the source. All your business logic should be in the database layer. So which means no transformations in Power Query and no calculated columns tables, because you're talking about enterprise data. So there should be a single place where you would apply your transformations, especially if you're dealing with millions or even billions of rows of data. So let the database do the heavy lifting, and also be the place where you can perform your testing and audits. Needless to say, you would need to design your views so that they become star schemas when you import them into Power BI. You wouldn't have just one star schema for your enterprise models. You would have lots of star schemas, which is okay. So one model I worked on had 24 fact tables, 16 dimension tables, and 44 measures. So all of those 24 fact tables were star schemas and linked to a few of those conformed dimensions. Try to avoid snowflakes as much as possible. Sometimes it's not possible to avoid, especially when dealing with multiple grains. Example would be your actuals and targets. So your actuals might be in one grain while your targets might be at a higher grain. So, and might be the only option is a Snowflake, but otherwise you would want to create star schemas. Also, be cautious with calculated groups. I don't tend to use them in my model simply because they require a bit more learning on the end users on how to use them. Uh, if you want, if the calculated uh, groups are required, so you can easily include them in the reporting layer, uh, because and then the reports can become a composite model. But I would be cautious to not include them in your enterprise models. So those were the main learnings from the design aspect. So you've done all the ideating, just brainstorm and build your views and star schemas. So now you're ready to build it. So another meme coming up. So this is a real test of your model. When you build something and you keep on adding new features, are you going to break it? If you design it well, your model will actually be very well usable. So I would the way I go about it. I still use Power BI Desktop, but I use it as a dev environment. So I use that for build, and I basically use that in such a way that the testing of the model happens in Power BI service, and the actual desktop application is used only to import tables, and I'll let you know why. So how do you actually start your build, right? How do you go about building your model? You would need to parameterize all your variables. So when you're importing from a DB, so you'd have a server name, a DB name, schema. If you have a prefix for a view, start date. So all these are variables which you can change in Power BI service. So and it's highly desirable to have them as parameters, because then you only have to change them once and not across multiple tables. Utilize query folding. And now you might be wondering, if there are no transformations in Power Query, why do we, why even bother? While you wouldn't have any transformations, you might want to filter your data. So you might want to remove some columns from the views and only bring in a limited amount of columns. So while doing that, just be ensure that you push all those transformations to the source. So and yeah, so because especially while filtering and removing columns, most of the time you should be able to utilize query folding. Also, you might want to filter your fact tables by date. Your views might have data going back 20 years, right? But there wouldn't be much point in reporting from what happened in the early 2000s. So you might want to filter your fact tables in the Power BI model to show only the last 3 years or 5 years, say. That's where you would filter it by date, and and just make sure that as you filter them, that it utilizes query folding. So you would want to import limited amount of data. So I normally just do about 100 rows per table in the fact tables at least. That's because when you're importing limited data, so you are working faster, and also you publish quicker to service. That's because it's not, you definitely don't want to import millions of rows of data into your model every time you make a small change. And also there are size limits in service as well as to how much you can publish in the Power BI service. Use external tools. You would want to use Tableau editor to automate your build. I mean, you simply cannot create enterprise models using the desktop QA. It's going to take you a long time and it's extremely inefficient. So I've got scripts which pretty much do the entire build, from establishing relationships to importing column and measure descriptions, applying formatting, hiding columns which are not required, uh, applying some encodings as well. So pretty much everything except importing the data, I use Tableau editor, and I just press play, and in a few seconds, you got your build ready. The other tool I would recommend is DAX Studio to performance test your models, especially if you have millions of rows of data. Uh, you might want to do some performance uh, tuning of your tables and measures so that they are optimal. And also ALM toolkit. It's very important that you use this toolkit to actually publish just the metadata onto a test workspace and not the entire model. I know a lot of people have at least a dozen or more external tools, but I find that I only need these three. I don't really see the need for other tools. So I'm quite happy with these three tools. Keep DAX simple. Simplified views lead to simple DAX. Your semantic models is not the place to show off your complex DAX. You need to have really simple DAX like sum or an average or a simple calculate with a filter. And that only happens when you actually do your design well. You have your bus matrix in front of you, and then you design your fact tables and create simple views. Beware of iterators and distinct count in large models. They can be pretty non-performant on larger models. Also, I tend to utilize extra fields in tables to help with DAX as much as possible, especially if you are dealing with filtering. I like to build flags in the model, just simple ones and zeros, which really greatly help me in my DAX, and my DAX becomes simpler instead of doing all the heavy lifting on the Power BI side. Follow DAX management rules. So what are these? This is based off a blog post I wrote about 11 rules of DAX management. You can find that on my website. So it's basically to ensure that your DAX or your measures are auditable, performant, readable, consistent, and discoverable. So it deals with naming conventions. So things like not using implicit measures and using explicit measures, and forming a consistent naming convention of formatting of your measures and also your expressions, and also making sure that your DAX is performant. So uh, whatever rules you have, but just make sure that you follow them for each of your DAX measures. So those were the learnings from Bill, right? So you've done your design, you build your model, you used all the fancy scripts and performance DAX. So now's the time to deploy it. So deploying means publishing a model from your desktop view to Power BI service where you'd want to test it and then push to production so that end users can start to create report from it. Deployment, it's again, it doesn't have to be as as hard as this. If you have done your groundwork right, you don't have to play with fire. So you deploy to test workspaces first, where the business would conduct the user acceptance testing. So ideally, the data should come from a non-fraud environment, which would ideally have a like-for-like data from fraud, because you don't want to test in a fraud environment. I normally don't tend to have a separate dev workspace. I use the dev workspace for proof of concepts and experimentation. So I tend to keep those separate from the test workspaces. So once you've finished your testings, so you would want to use deployment pipelines to push to prod. You can use tools in DevOps like the automation tools extension to automate it. It is highly useful if you're deploying multiple models. And you can also set up some approval processes so that people can see what you're deploying. Automate model refresh. You should not be using the scheduled refresh. Use Power BI REST APIs to refresh the models after your table reloads are complete, because you never know when a table or reload is going to finish. Sometimes it might take 2 hours, or it might take 6 hours. So it's ideal to actually use the API to refresh it only after the tables have the new sets of data in the database. Also enable large storage format. That definitely helps with your refresh as well. Monitor model refresh. So if you use Power BI Premium, so you can use the Fabric's capacity metrics to monitor your refreshes. So it's got a whole lot of dashboards and visuals to not only monitor the dataset refreshes, but also the CPU consumption as well. If you want to do something more fancy, the capacity metrics app only has history for the last 14 days. So it's like a rolling 14 days. But you could use Power Automate to extract the refresh times to track history for more than 14 days. So you could set up a Power Automate to download the refresh times of your models, and then in a separate Power BI report, ingest those refresh times and track the history, which is so you can, and that way you can track your history for more than 14 days and not just rely on the Fabric's capacity metrics app. You can also use SQL Profiler to set up refresh traces and analyze the results. There's a blog article, I think, by Phil Seamark, who basically shows you how to on how to set up the profiler to set up a trace and then analyze the results of your refresh. So basically, so you can tell from the outputs of the trace as to which tables are taking the longest time to load in your model. So which So which could be a hint to actually for you to go back into your views and see if you can do some performance improvements to make the tables load faster. So you've deployed everything, and now what do? Just sit back and relax? No, you'd have to support it. You just can't expect the end users to no uh, uh, just query the model without proper support. So how many times have you seen that, there is just this one guy doing everything, and all the documentation is in that guy's head? So yeah, don't be that guy or girl, and just make sure you provide as much support and documentation of your models as possible. Uh, it all starts with version control. So if you have premium capacity, so you can use the Git integration in workspaces. Uh, it's a fairly new feature, but it takes a while to get used to it and set up. But it's a good way to do version control. Do not keep copies of PBIX files. You'd want to use the same PBIX files and not keep copies of it, because they can get too large. And you can use tools like VS Code for committing to DevOps. Documentation. It's a bit of a bugbear from the Power BI side as to how would you document it. You could use Confluence or SharePoint, but it's a bit of a manual process, because every time you update the model, you'd have to update your SharePoint or Confluence. And there are third-party providers as well who provide some amount of automation, but that's an extra cost for you to actually use those tools.
Sorry,
Or,
Abby.
yeah,
Sorry to interrupt. There's been a question on the chat. Have you tried Azure Purview, and what do you think of it if you have?
I haven't tried Azure Purview, but so what's the use case specifically for Purview?
Well, I suppose around documentation, Purview provides data lineage and data cataloging, etc.
Yeah, so I have not used Purview, but what I've done is I actually have a dashboard which uses DMVs to extract the data from your models, especially if you have a premium capacity and the XML enabled. You can extract a lot of data, and you pretty much can use that to build a glossary dashboard, which provides pretty much all information about your models, like how many tables are there, how many measures, your measure expressions, uh, which columns are being used in which measures. Uh, I'll probably be I'll probably do a talk on this at some point, but yeah, you can use DMVs to extract and get your documentation.
Thank you.
Optimized model. Models would require constant fine-tuning. I tend to use some optimization strategies and processes in the design and build. Things like setting up the right encoding for your integer columns, uh, setting your MDX flag as false for fields not used in decoding. So they greatly help in your refresh, not only your refresh, but also decreasing your model size. And also things like transaction amounts in large models. Even though you might set the value in encoding as the hint as a value type, but Power BI thinks that the hash encoding is a better gives a better compression. So in that case, you might want to split your transaction amounts into a whole component and a fraction component, so which would greatly reduce your model memory. Also monitor your measure performance. As your models get bigger, your measures might start to degrade. So it's important to keep monitoring them and to make sure that the measures are quite performant. Automate model testing. So what is this one? So you'd want, how do you ensure your DAX measures are giving the right output, right? So you would want to test them against the SQL equivalent. So what you could do is, so given the DAX measures, so you could write out a SQL equivalent of it, and maybe just create a stored procedures for those SQL statements for those measures, and then bring them into Power BI, the outputs of those SQL statements, and compare them against the DAX measures. If you've done your design and build well, it should be a lot straightforward, those SQL statements, because if you're using, a really simple DAX measures, then those SQL statements would be pretty straightforward. But if your DAX gets really complex, then you might struggle to write some good SQL. All right, so how does it look like, putting everything together? So say you have a data source. So this is a really simplified view of the whole process. You have a data source in the presentation layer. So in the views, you have sit environment and the prod environment, and then you have your development deployment process. So you have your Power BI desktop and your tables here, and at the bottom you have your version control and deployment. So what you would do is, so you would import limited data from sit, do all your development inside desktop, sync it to OneDrive so that you don't lose your PBIX file in your local drive. And once you've built a few tables and measures, use ALM toolkit to deploy it to a UAT. And at that time, you would bring in all data from sit, perform your testing, commit your changes to DevOps for deployment, and you would have approval process to approve those changes. And once you have that, you can, so depending on the deployment, if you're deploying tables, you would want to deploy those tables from sit to prod in your DB first. And once that's done, you can use deployment pipelines and call the API to deploy those tables from the UAT environment in Power BI service to prod. And then in prod, you can import all data. And that's where the parameters come into play, because you can have different values for your DB and servers in your sit and prod environment. And that's where it'll pick up the right DB and servers server names. So that's pretty much what I had. In conclusion, do not over-engineer. It's really easy to actually over-engineer and do some really complex things within Power BI with DAX and stuff. But think of your role as a small role in a larger system. So like you have a role to play, but your role is not greater or lesser than the other people working on your project, like your data engineers and analysts. So as much as possible, keep your models simple and move your transformations onto the source. Also, keep end users in mind in terms of how your models are being queried. So keep consistent names for your table names and measure names, and make sure you monitor them for performance all the time as well. And lastly, stick to the process. It's very easy to take a shortcut and build some transformations in Power Query because you have a deadline or to build a calculated column. But ultimately, all that does is it's a tech debt which you have to roll back at some point. But if you keep adding those Power Query transformations, in the end, you won't have an enterprise view of your model. All right, that's it for me. I hope you found this useful. If you have any further questions, please let me know. I'll be happy to answer them.
Thank you, Abby. Very much appreciated. Really, some really good learnings there for others, especially those who are starting out, to be able to follow. Thank you. Any final questions for Abby before we sign off for the night? Feel free to come off mute and just ask your question.
Hello, just Andres here. I would like to ask a question. So I saw in your diagram that the data warehouse should go and link straight away to the semantic layer. Will you suggest still to use data flows, or now building the semantic layer will be actually better just to connect directly to a data set instead of using data flows?
I've never used data flows in my projects, but I guess it depends on the use case, right? If the project you work on insists on using data flows, and if the data flows can handle those amount of workloads, which I don't know if it can or can't, so I can't guide you on that. But if you work on a project where you have the setup in such a way that you have a database, and then like you want to do the heavy lifting on the database side, say this is the Azure stack, then I would actually just do it this way. Just define your views and then have everything in one model as much as you can, because it just, I feel it creates simple things like auditing or testing. It becomes a lot easier when you have just one model, because most of the time when someone says that okay, this measure is supposed to be 100 million, but it's not. The issue mostly lies in this layer, right? Because you built your simplified views, and your measure is just a sum of the transaction amount field, right? So the in terms of testing and auditing, it's probably it's the data engineers or the testers would go and investigate the transformation layers and see where the problem lies. But if you build everything within Power BI, if you have
So if I could jump in there, Abby, because I do have quite extensive experience with data flows. What I'd say is if you have a proper data warehouse, there's no need for data flows, or there should be no need for data flows. If you have a proper data warehouse and you still need data flows, then the data warehousing team probably hasn't done their job properly. There's also been a follow-up question around that on the chat about does it create performance difference when you use data flow, data mart, data sets. Data flows actually introduce additional time into the refresh process. So again, if you have a proper data warehouse, do not use data flows. That's my default attitude, and I'm yet to be proven wrong in that.
So one more question I have. So if as you said that it doesn't create any difference, so what is the benefit? So if we already have a data warehouse, proper data warehouse, so you mean to define a semantic layer, it is good to do in a data flow, or still it is advisable to keep the semantic layer in the database itself?
No, what I'm saying is, so if you look at Power BI, you got your what are now called semantic models, and until a month ago was called data sets, right? If you have a proper data warehouse, like a SQL Server level data warehouse, then data flows do not add any value to that scenario. I would just go straight from your data warehouse into a data set or a semantic model, as we call it today. And it looks like we've lost Abby. The data flows in Power BI are there to help organizations that don't have a data warehouse, a proper, well-managed data warehouse, to sort of have centralized. If you think about if you've done a good job of data warehousing, you will have a single DIM customer or DIM product. That's what data flows are there to help the organizations that don't have that, to create that in a simple Power Query, easy to use way. But if you have that proper, well-managed data warehouse within your organization, then data flows, in my opinion, are just actually getting in the way. Because you have to process them separately from the Power BI data set. So they actually slow the process down. I go back to when data flows first came out, probably about 4 years ago. What everyone in the know at that time was saying that it's a poor man's data warehouse. And by that, they meant the organizations that couldn't afford to do proper data warehousing would use data flows as an alternative. And it had a lot of benefit for that. I've seen numerous situations in which that's been really beneficial to people. But if you have that data warehouse, then data flows should not be adding any benefit to your organization. And if they are, well, then your data warehouse people haven't done their job properly. I hope that makes sense.
Yep, that answers the question. Thank you.
Unfortunately, it looks like we've lost Abby. But look, it was. Oh, you're back, Abby. Thank you.
Yeah, sorry.
That's all right. Are there any other final? I'm just looking through the chat here. A question that I think is probably really important is, do you recommend one semantic model per enterprise or per business area department, like sales, logistics, and use composite models?
Yeah, I think one model for enterprise might be a overkill, because you want to have one business unit does all the data from a business unit, have your stakeholders from the data and define what the metrics are. So you would have, in this case, probably sales semantic models, which would have its own little views, measures that you might have. Logistics one, I mean, at least I think that's how I would go for it on. Like, say in a banking example, so you have a customer one and you have an HR one, so it should be an internal semantic.
Sorry, Abby, you are breaking up quite badly. I'd say we're losing every second or third word, but I think what you're saying there is that you would go the latter, which is to have smaller semantic models per business function. Is that correct?
Yes.
Okay. So probably a follow-up question there is any advice on developing an enterprise-wide management KPI report if you have different large semantic models? Susan, I think the answer there is that we now have the ability to do composite models as per the previous question. So there's actually no reason why you can't have the multiple semantic models that are then combined into a single report using a composite model. Oliver, I think that's quite a long conversation. You can maybe reach out to me on LinkedIn or on Meetup, and we can have an offline conversation around how to get rid of data flows from your organization. There's so many variables and factors that are involved in that, but I'm more than happy to have the conversation with you. Okay. Listen, with that, I think we'll call an end to tonight's session. If your questions weren't answered, please either reach out to myself or Abby on LinkedIn. Both very active there, so and we'd be happy to help. With that, I want to, as I said earlier, wish everyone a happy festive season and be safe. And we look forward to seeing you all back in February. Thank you very much. Have a good evening.